So we can't go to those things in my calendar. So there's 6, 8, and 10. I wouldn't not if you're scared, but fear them getting lost. I mean, there's only one way to go. They will find a way. Trust me. Owen and Emily are good at
Why is it so hot in here?
Well, I could say something, but I'll refrain.
Oh, I feel like I know what you're missing.
Hi, man. Chris.
Oh, I got this.
Yes, because Nathan finally finished his test. Haley.
I don't even want to look at it. Sorry, I'm sorry. She's trying to buy me a fish. I'm gonna eat it.
You won't.
Harlan. Josie. Hey.
We can't have fish.
So now I
Hey, one quick note. Hey, listen, please. Yeah, I don't mind a little bit of chit chat going on, but that's crazy. Right? Serious talk.
Oh, it's Riley. Yeah, I got
Hey. Don't beat yourself up. Road. Mike's not here today?
No, the odds are out.
Billy. Landon. Landon got the only perfect pick. Order.
Easy, Josie. The reign of Josie is over. What problem was easy? Oh my god. I went crazy. Let's take all time. 26 Nicholas.
All right, listen up. Five, please. Okay, that was once. Guy. Thank you. Okay, so the scheme of challenging tests, let's say easiest to hardest. This was a medium one. The harder tests are coming, right? This was not a hard test. This was a medium test. So for those who did it very poorly, right? I'm just going to say, you know, the onus of improvement is on you, right? I would just encourage you to do 3 things. 1, pay more attention in class. 2, don't blow up your homework. Not most of you guys do fine on the homework. I'm saying some of the students that did very poorly, you know you had multiple missing assignments. And then 3rd, if you wait until the test to find out you don't know this, right, it's too late at that point to do anything, right? You know as I'm teaching you this, whether you get this or you don't. When you start learning this, you're like, I don't know, he's saying words, I don't even know what it means. And you're not doing anything about it. Hey, I walk into your classroom every single day, right? Rarely, except for maybe Riley, now you got me saying it. Kaylee, rarely do I have anybody, Kaylee, ever ask me a question, right? Occasionally. If that's the case and you know it, then you should have an A in front of your face right now. Congratulations goes to you. Landon never asked me a question. He got a perfect paper. That's impressive on an algebra test. you have perfect paper. It's hard for that many steps not make a silly mistake. Look at your mistakes. If you made a silly mistake, I said to a couple people, don't beat yourself up. You know, it's just the way the algebra goes. I drop negatives like no tomorrow on an algebra test. I'll still get an A, but I also won't beat myself up, you know, too much about making a silly mistake. If I put a question mark on your test, it means I have no idea what you're doing. None. Right? Not sure where you're getting your ideas from. I do circle where you make your first mistake, and occasionally I'll write the whole darn problem just to show you what you should have done. I'm not going to go over every single question. What problem was hard? There were only 2 people that got it right. One of them, Landon, I know I had a brain seizure after reading all his work.
Look at it. This is the Jackson mess.
It's just, I don't know. You know who Jackson Pollock is? The artist? He's the guy that's famous for literally putting dribbles all over everything. It's just a mess of paint all over the place. He has a Jackson Pollock hand. It's right, by the way. So somewhere in his guess and check, he got to it. There were a bunch of people. Anna was one of them. I think Lily was another one. There's like 3 people who came up with the equation to solve this, and then they weren't sure what to do about it. A couple of you came up with the right equation, but you wrote it slightly wrong. Remember, dollars and cents is hard. If you're putting it in terms of dollars, right, a quarter is 0.25 then. If you're putting it in terms of cents, then $5.55 is 555. So a few of you I want to say it was Riley. It could be wrong, but she wrote that out and then tried to solve it with 5.55. Was that you? Did you try to solve it with, or was that Amy?
I don't.
One of you somebody out there tried to solve it with 5.55, and it just didn't work out really well. You got some weird answers. Why? Because, well, if you wrote cents as 25 quarters, or 25 times the number of quarters, and then the quarters in nickels? Yeah. And then 5 times the number of nickels, and then you wrote that as 5.55, that's why it didn't work out. It would have worked out with 555, you would have got the right answer. There were 2 people that got, Riley, who's the other person that got the right answer? You did? How did you get it? Guess and check?
Yeah, and I ended up using tick marks. That's how I did when I was doing it.
This would have been a hard one to do with a guess and check, but clearly at least 2 people could get that. The rest of you, some of you put some questionable work down, right? And I tried to show you the lunacy of your guesses. One person guessed, I don't know, like 4 quarters, right? Or maybe 4 nickels or something like that. And I said, okay, great. You got 4 nickels, there's 43 coins, at least 39 quarters, right? 39 quarters is a lot more than 555. All right, any specific questions on the test? Yes?
Why did I lose points for doing their answer? From, like, I know maybe the mistakes is the word wrong, but
So, on this one right here, first off, it's not no solution.
oh, okay. Yeah, no.
Well, I only took away 1 point because you told me the answer is no solutions, and it's all real numbers. So I only took off 1 point. Okay, no other questions? All right, put that away. All right, Haley, you've seen your test, correct? Haley, are you listening? Okay, speech time. Listen up. Hey, this is a medium to hard here. This is a medium to hard pass back. This medium to hard chapter. We just did the easy stuff of the chapter, which was add and subtract. Of the 2, the only one you got to be careful with is subtract. And when you subtract, remember you got to change all the signs of the second polynomial. None of you complained yesterday as I taught. You had a little bit of extra time before the end of class. You guys were like, okay, I know how to add and subtract. Okay? Today we're moving on. It's going to be fast-paced. Today we're going to learn multiplication. Tomorrow we're going to learn power with power. It's going to be quick-paced. The way you get through algebra is one, you pay attention, and two, you ask questions in the class. You don't wait to the end to say, I didn't get any of that. You ask the questions while it's being taught. What's up? Are you? Okay. Some of you might know these rules already. Most of you don't. This was taught in pre-algebra. We're going to a much higher level than pre-algebra with this. Yeah. Front and back. Front and back. Bless you. Okay. Homework tonight. Oh, by the way, somebody remind me to collect homework. Okay.
Collect homework.
I meant later. So I will collect it. Homework tonight is as follows. Calendar quiz tomorrow. What will the quiz be on? I said it will be on adding and subtracting and the names of your polynomials, degree name and term name. Yesterday, I walked to everyone that was clueless. Literally, I walked to everyone that was clueless, and at the end there, you were all like, okay, I'm not clueless. I got this. If you forget your resource card tomorrow, guess what? You're not going to remember whether that's a linear, quadratic, cubic, or a constant. That won't stick with you. You'll probably remember binomial, trinomial, right? Make sure you have that resource card with those two tables. If you have it memorized, great. I'm going to submit to you that you probably don't. Make sure you have that resource card for the quiz tomorrow. The quiz is going to be on, I'm going to give you a polynomial. You're going to tell me its name, both names, term name and degree name. And then the second thing was what we had for homework last night, add and subtract. What we're about to do, not on the quiz. We good? All right, homework tonight. There it is.
Oh,
Right. Bless you. Homework. See your homework? And then I need to turn around.
what was that noise? Shaquille O'Neal call.
Okay.
The Shaquille O'Neal.
So here's the deal. Much of this is going to be quickly shown to you. I'm going to go at the pace of, I don't know, the slowest person, but it's still going to be quick. Right. Sure. All right. Somebody back there? Yes. All right, here we go. Multiplying monomials. Okay, yesterday we were add, subtract polynomials. Now we're going to multiply monomials. This steps up really quickly. Today, right, hopefully this isn't new, but we get to multiply polynomials really quickly. Okay? But instead of starting off with multiplying polynomials, we're just going to multiply monomials. And then we're going to multiply binomials. And lastly, it will be trinomials, but we'll just say multiplying polynomials. All right, recall from previous classes. The big number is called? And the small number is called? Or power. Exponent or power. Yes? What does it mean? I take the base and I write it how many times? What does it not mean? Are you sure? Occasionally I still see kids in high school want to do 5 times 3, right? I'm not sure where that comes. I know where it comes from, but no math teacher has ever said that it's the base times the power. In fact, they don't say that. They say, hey, remember, it's not that, and yet kids still do it. Okay? The key concept here is this. When you have exponents, the base is written the number of times that the exponent is. In this case, the exponent is 3, so we write the base 3 times with multiplication in between. Exponent's a way of showing repeated multiplication. Okay? Large number. Okay? It is not 5 times 3. 5 times 3 is 15. The answer is 125. Okay? There are some exceptions. 2 to the first power is 2. So it's 2 times 1. But those are exceptions, not the rule. Okay? Today, tomorrow, the next day, the rest of the year, we're going to be dealing with exponents. Pre-algebra, yeah, we had a section on exponents. You didn't deal with it every day. From now on, everything we deal with will have an exponent. Okay? Key concept is this. Well, yesterday we added things that had exponents, right? We added 5x squared plus 3x squared, got 8x squared. So we were adding things that had exponents. Today we're going to be multiplying. If you've never had this explained to you, well, let me explain it to you. If you don't already know the rule, Sarah showed me the rule. Chris, do you know the rule?
What? Oh, I already know what I'm doing.
That's literally what I just said. Chris, do you know the rule?
For what?
What's the answer?
We're doing, all right. Yeah, I'm sorry, I spaced out.
You can say no, and I can do this quicker.
Yeah.
All right, thank you. No. So for those of you that have never had the rule explained to you, I know you know it, but can you explain it? And don't tell me you had. So for those that need the explanation, this isn't magic. I just say, hey, trust me, this works this way. That's magic. I'll show you how it works. Well, how it works is this. Well, 5 to the third power, as we previously learned, Julie, is what? 5 to the third can be written as what? 5 times 5 times 5. So when we're multiplying, and we don't know what the answer is because we can't remember the rule, well, we can always say that 5 to the third power, Julie said, is 5 times 5 times 5. Well, multiply means multiply, so what do I put right here? Okay. What's 5 to the fourth? Oh, that's 4 5s, right? So blue times, I don't know what that color is, greenish, something like that. All right. So that times that would be this, but this is just repeated multiplication. In other words, I could write this as 5 to the 1, 2, 3, 4, 5, 6, 7. Go ahead, Sierra. So this tells us why the rule is just add the exponents. But we got to put one caveat. Caveat means exception, right? The one exception is this. The only time that are you paying attention, Chris? The only time that you can do this is when the base is exactly the same. Hey, what's the base here, Chris? What's the base here? We can add the exponents. If the bases are not the same, you can't do this. Okay? That is the rule. By the way, I taught you this if you had me in pre-algebra. Okay? But that's the rule. Okay? So the rule is when the bases are the same, you simply add the exponents. What's up, Josie?
And then if it's in parentheses, to change it.
We'll talk about parentheses here in a second, and it does. Okay? 3 plus 4 is 7. We get 5 to the 7th power. Yes? Okay. We need to write this down. In your book, this is how an algebra student would write this down. The general rule says this. If you have something to a power, something to a power times the same base to a power, you rewrite the base and you add the exponents. This is box 1. Box 1. If you have something to a power times, hey, look, same bases, to a power, you rewrite the base and you add the exponents. If you need it in words, right, the bases have to be the same. And you never, ever, ever multiply the bases. You never, ever, ever multiply the bases. Sorry, Mike.
What if they're different?
I'll show you that here in a second. Good question. So the rule is, the rule is when the bases are the same, you rewrite the base and you add the exponents. It's simple. It's not even complicated. And it's adding. Oh, it's Algebra 1, so the exponents could be positive or negative. Could also be 0. When you get to Algebra 2, they could be fractions or decimals. Not in Algebra 1, though. Chris, you got it written down?
Yeah. Okay.
We good? There's 2 exceptions right here. Let me show you that on a separate slide. Okay? Don't do this. You know, I've debated whether or not I should ever have slides like this of don't do this. The kid that's not paying attention will do this. Don't do this. Guess what you shouldn't do?
Multiply the
So the answer is not
5. 6 to the power 7.
6 to the power 7, right? The bases are not the same. You can't do this. Question is, what do we do for this? I'll show you in a second. Okay? Well, that means 3 4s times 3 2s. That's what you got to do. When the bases are not the same, well, then you're in for a treat. right? By the way, in Algebra 1, we rarely deal with things like this because our base will almost 99.9% of the time be a variable, X, or Y, or Z. Yeah.
What if you have parentheses? What if you think
We'll talk about parentheses in a second. I don't want to get ahead of myself.
I don't want to do parentheses.
The second thing you should not do is what?
Multiply the exponents.
You don't multiply the base, ever. Ever, ever. Never do that. I will have kids do that, right? So once again, I debate whether I should ever show this slide, right? I try to make it in red, right? Oh, by the way, what's the answer here? 3 to the 7th power. Okay, there. Now, you're probably asking yourself, wait, do I do 3 to the 7th or do I actually calculate what that is? Okay, we will rarely ever have a number like this. If it's 2 to the 3rd power, you can do that. 3 to the 7th, heck no. Plus, you're not going to see that, right? Or they're not going to give you a 3 to the 7th. Okay, so the rule says multiplication with exponents. If the bases are the same, you rewrite the base and you add the exponent. So the answer is
3 to the 12th power?
3 to the 12th power. Do you need to write this step?
No.
Clearly not in Algebra 1. Pre-Algebra, I make them write that.
So that's
But not in Algebra 1. Well, it gets a bit more complicated, but that's the basics, right? What's the answer? Okay. Once again, that's pre-algebra. That's pretty simple. You can look at where we're going on the sheet of paper. Okay. So on your own. Oh wait.
So 10, 24.
Well, it's 24 plus 0. It's just 24. Don't overthink it. Follow the rule. All right. Do box 2, please. Quickly. Should take you about 10 seconds. 10 seconds. Porter. What? You're sending me hand and arm signals. I'm not sure what they mean, but.
None. That was easy. I mean, cool.
All right, Tristan, the first one is
4 16.
4 to the
4 to the
4 to the 16th power. If you say 4/16, that means 4 point.
It's like 16.
Right? Well, not 4.16, but 4/16 would be 4 over 16. That's 4/16. Okay. All right. Bottom one. Brandy, what do you got? That's the 12th power. Okay. Upper right. What do you got, Julie? What'd you say? Have you had this before, Julie?
No.
Okay, good. You just learned it. Good job. It seems easy. Rowan, the last one. How many people already know what anything to the 0 power is? It's not 0.
It's itself.
It's not itself.
It's 1.
It's 1.
So it's 24.
So it's, well, what? So 10 to the 0 power is 1. So this is 10 to the 24 times what? That's just 10 to the 24. Or follow this rule. Same basis, just add the exponents. Okay? Once again, I don't expect, at least in Algebra 1, you can write the step if you want. Show me your big brain. But yeah, I don't expect most of you to do that. All right, this gets way more complicated than this. That's the pre-algebra. Now we're into Algebra 1 land. All right, Algebra 1 land, we deal with multiple variables. It's still multiplication. Multiplication is commutative. We can move things around. So if I move this A next to that A, oh, wait a minute, it doesn't have a power, or does it? What's the power?
1.
So I'm not going to show here, at least for today. I'll stop doing this pretty quickly. But remember, that's really A to the 1st power. It's just not written there. We're lazy. So we group A's with A's, B's with B's. What do you get?
8 to
A to the 4th times
Oh, yeah.
B to the 9th. Do I expect you to write this step? No, but that's the math behind the answer of A to the 4th, B to the 9th. Yes? Okay. If you need a guiding light, here's your guiding light. When you multiply, same letters, this is not adding, right? Same letters with same letters, right? Numbers with numbers. And you'll see what I mean when I show you the next example. Hey, I got numbers and I got letters, variables. Once again, if there's no power, it's
1.
Well, technically, 3 is to the 1st power, and 6 is to the 1st power as well, too. Okay, so when anything is to the first power, you can multiply it. What's 6 times 3? So this isn't the distributive property. I know I'm putting arrows here, but it kind of has that flavor, right? So I'm going to group the 6 and the 3 using commutative property. 6 times 3 is, okay? And now I group the A's together. What do we get? Oh, there's an Algebra 1 problem right there. Okay? So I get 18A to the 4th. Chris? Yes or no?
Depends.
Okay, why did I get 18?
Because you multiplied 6.
Numbers with numbers, variables with variables, letters with letters, I say it. Why did I get A to the 4th, Chris? It's just 3 plus 1. Okay? All right, here's some special ones. Okay? These are called special because check it out. What's the base? What's the base? You can't multiply them together. I'm saying you can't just rewrite a base. So you can do this with the A's. A's are the same base. So that would give me A to the. So what am I going to do with these two things? The actual math. What is 4 to the second power? What is 2 to the second power? So when you have dislike bases for these numbers, right, then you actually got to do that math. So I need to write that as 16A squared times 4A to the 6th. Stop me if you're lost, right? Previous problem, it was 6 times 3. We can multiply 6 times 3. Why? They're both to the first power. But when they're not both to the first power and they're different bases, you got to do the actual math, right? The rule of rewrite the base and add the exponents does not apply. This is one of those exceptions. So, and you'll see this, right, tonight for homework. So we have to write it like that way. And then, well, now what? Somebody help me out. Now what? 16 times 4 is 64. A to the 8th. If you're sitting there and you're lost on how I got that and you're not asking a question, shame on you. Okay? You'll understand why you get the F when you take your test. But if you're sitting there like, what's he making a big deal of it? I had the answer 20 seconds ago, good for you. Right? I get a whole group of people. Some people like to participate, Brandy, and then some people don't like to participate, right? Yes. Yep. No. You group letters with letters, numbers with numbers. The reason why we couldn't say 2 plus 2 here for this one is the bases are not the same. Okay? The A's we can. We group the A's with the A's. We group the numbers with the numbers. But the problem with our numbers here, this is a 4 and this is a 2. The bases are dissimilar. If this was to the first power, life would be good. You can multiply 4 times 2 when they're both to the first power. But when they're not to the first power, you got to do the math. Contrast that with the previous one. Hey, 6 is to the first power, so is 3. We're able to multiply these together. But any time that the bases are not the same, you can't do anything other than the normal math. When it's a variable, well, there's nothing left to do. But when it's a number, we can take 6 to the third power. That's not what this one says, but if it was, we could do that. So this is why this one is 16 and this one is 4. The bases are not the same, so we got to rely on old trusty. We got to square both those numbers. All right, any other questions? They can get more complicated if I throw some negatives around. Hey, what's a negative times a positive? We know the answer is negative. Hey, Kaylee, first power. Can we multiply these two together if they're both to the first power? Yes. If this was to anything other than the first power, then we would have to expand and multiply. Hey, what's negative 2 times 3? And what's x to the 10th times x to the 6th? X to the 10 plus 6, which is x to the 16th power. So we get negative 6, x to the 16th power. I'll ask again. Are we okay? All right. If you're not okay, this is where you say, you stop me. And you're like, I don't get this. When no one stops me, I move on, Chris.
It still depends. Like, I don't know.
Okay, so how come you're not asking questions? Did you understand where I got that from?
Yeah.
Okay, then you don't have questions. I'm not saying you've got to ask questions. But when you're looking at this, you're like, that's a whole bunch of nothing. I don't even understand what any of that means, and you do nothing, but you're not doing your job. Yeah. What's a negative times a negative? Positive. Okay. Julie, can we multiply 4 times 3? Yeah, as long as to the first power you can. If this was 4 to the third and 3 to the second, we would have to expand and multiply the 4 to the third and the 3 to the second power. What is 4 times 3? What is x times x to the 6? Julie. What is x times x to the 6th power? You're killing it. So final answer would be, whoa, back up. Perfect, good job. You're gonna either stop me or we're moving on.
I'm ready.
Okay. Do box 3, please.
Here's the box.
Are you good? Chris, you confident?
This is like, I get it, but then I don't get it. So like, just go with here now.
Okay. Piper, yeah?
So what if
Oh, x is with x is y and y.
Negative 15r on the 5th power s to the 4th. Good job, buddy. I think that was
Yeah, I got it. So it'd be y to the
If you pay attention like this every day.
yeah.
Okay, there's going to be some hard stuff. Yeah, good job. Kaylee, which one?
the last one?
All right. Kaylee, what you get for the first one? A's with A's, B's with B's. So A would be to the, where are you getting a 7? You just added B to an A. A's with A's, B's with B's. This is how she's going to fix her mistake. So what do we get for A, Kaylee? B to the, okay. Chris, the middle one?
Yeah, okay, wow, I'm sorry. It's x with 3, no, x with
X's with X.
11.
Keep talking.
And y with 19. No, y with 11.
Okay, very good.
yeah.
Yeah?
Good job, Kurt.
All right, Kaylee, what was your mistake, or what was your complication on the last one? Okay, do it. All right. Aiden, what do you got? Last one. Okay. Aiden got this. Yes? Hey, I will warn you if you're checking the back, look at would I sign odds or evens?
Evens.
Okay, so you don't have to worry about it. Occasionally the book will literally write whatever 4 to the 7th power is. It's a really big number. All right, the most complicated one, there, I'm going to show you 2 different forms of it. Well, why is this more complicated? There's a lot more things going on. It's not complicated. It's the same thing. So although I said the most complicated, it's okay, it's the most work, but it's not, the last one is the complicated one. All right, so let's see what we get here. What's a negative times a positive?
Negative.
So we know the answer is negative. Okay, Harley, what's negative 2 times 5? What's it? Negative 10, okay. Harley, group the X's, what do you get? And the Y's? Questions?
No, that's actually
Okay. So if this is the most complicated one, it's not too bad. Hey, Tristan.
That's not the most complicated one.
It's not. It's not. The last one is. Okay.
I already got it done.
Oh, wow.
Now, I got a 3 here. What's the number over here?
1.
Negative 1, right? Because remember, there'd be a 1 right here. So what's negative 1 times 3?
Negative 3.
Yeah.
X is with X. What that's going to give me?
X1. No, X2.
And Y's with Y's?
5, 6.
Y 6.
There you go.
What?
Questions? I said I'm going to go as fast as you can take it. Okay, I'm going to claim that although this looks complicated, it's not as bad as it looks. Hey, what's the basic rules for multiplying with fractions? Nathan, what's the rule for multiplying with fractions? How do you do 1/3 times 4/5? What do you do? Quiet, please. If you can, there's nothing there. So what's the rule to multiply with fractions? Okay. Aiden, what's the rule when we multiply with fractions? Okay. Mike, what's the rule to multiply with fractions? All right, everybody needs to listen. I called on 3 people and not a single person got. Not granted, some of you do know the rule. The rule to multiply with fraction is you multiply straight across. Straight across. So Mike, what's the answer? 4/15, right? So that's what we're going to do for this one. We're just going to multiply straight across. So Nathan, what's the denominator turn into? Well, that's easy. The numerator, 12 times 20. What's 12 times 2?
12. No, wait, what?
And add a 0, so therefore we get 240. X's with X's, we get. And Y's with Y's, we get. Okay. So how we get that? Now I got to reduce. What goes into 240 and 15? What goes into 240 and 15? 5. 5 goes into 15. 5 goes into 240. 40. What? 48. Is that right?
48 times.
Okay, 48 times. Does 3 go into 48?
Yeah.
Do you guys know the rule of threes? Rule 3 says add these two numbers together. 4 plus 8. 4 plus 8. Does 3 go into 12? So 3 goes into 48. That's the rule of threes. I know I wasn't asking that question. We were just seeing, does 3 go into 48?
Oh, this is easy.
Oh, so 48 divided by 3 is, so what's the final answer?
6, 8 to the 4th power b to the
16.
Oh wait, oh sorry, I was on the 1/4 bar.
16 what?
16 x to the 5th power y.
Now, can someone tell me what I did that was way too complicated there?
Too much steps.
Multiply across.
Okay, multiplying across, how many people would say there's an easier way? Julie already knows the easier way. Some of you might know the easier way. Now listen carefully. If you didn't immediately know what the easier way is, then do it this way. I'm about to show you something that is fraught with error. It's called cross reduction. Remember that?
Yes.
Okay, I'm going to do the second. By the way, what's the answer? The hardest thing here was 20 times 12 and then reducing that sucker, right? So there's an easier way. I will show it to you. This is the easier way. It's called cross canceling. You can only use this for multiplication. You can't use it for division until you do copy dot flip. You can't use it for addition, subtraction ever. But when it's multiplication, you can do something called cross canceling. You look at the numbers, not the exponents, just the numbers. I got a 12, 5, 20, and 3. We make this X thing. I'm looking at this number and this number, 5 and 20. What goes into 5 and 20? 5 does. Okay? I look at the 3 and the 12. What goes into 3 and 12? 4 doesn't go into 3. 3. And this is the, I'll make it nice and neat now. This is the cross reduction. You said 3 goes into 3 and 12. How many times does 3 go into 3?
3.
4. 1 time.
What?
How many times does 5 go into 5?
1.
How many times does 5 go into 20? So that reduces to a 4 and a 1. I don't put the 1 because I'm lazy. 3 goes into 3 how many times? I don't put a 1 because I'm lazy. 3 goes into 12 how many times?
4.
Now when we multiply straight across, what do we get?
15 x.
We get 16 and we're done like that. You're like, well, when do we reduce? You don't reduce. Oh, by the way, it's called cross-reducing because you actually are reducing. So if you use this method, please, up here, if you use this method, you can save yourself a lot of work. What's the downfall of this method? It's messy. It's messy. I did it with PowerPoint. I drew things nice and neat. When I do this by hand, I got to slow down. I got to write my numbers very legibly because you're usually writing very small. Why are you guys packing up? We're not done. When I do this myself, I write really as best as I can. I always do cross reduction. It will make the problem easier. It's also not a requirement. We got the same answer. If you don't ever want to do cross reduction, you do it right, you will get to the same answer. Why are you packing up? I just told you, we're not done. Put your bag down. Thank you. Let's do this together. All right, you want to multiply straight across, or you want to do cross reduction? Let's do cross reduction. Okay, what goes into 2 and 8? 2 goes into 2. You should be writing with your pencils. 2 goes into 2 how many times?
4.
So I scratch through it. Some people will put a 1. For me, the cross through is the 1. It's just less things to write. 2 goes into 8 how many times?
4.
So I cross through the 8 and write a
4.
What goes into 10 and 15?
5.
So I cross through the 10, 5 goes into 10 how many times?
2.
So I put a 2. Hey, boys. 5 goes into 15 how many times?
3.
Cross through it, I put a. Now mine are in red, they're neat, and you can read it. Yours are probably not, says neat, right? You just need to be careful. I'm no longer reading those numbers, I'm reading the red numbers and multiplying straight across. 3 times 4.
12.
1 times 2.
1.
So I get 12 over 2, which is 6, because there's actually one more reduction we could have done. What goes into 2 and 4?
2.
So that could have canceled to a 1, and that could have canceled to a 2. This is why cross reduction is easiest. Now, if you did not see that, you multiplied straight across, you get that. But then you would see, oh wait, 12 divided by 2 is 6. 3 plus 1 is 4. 1 plus 2 is 3. We get to our final answer. All right. This is an Algebra 1 type problem right here, not a pre-algebra. So the difference between a pre-algebra and an Algebra 1 is there's just more things to multiply. There's more things to cancel. The numbers get far more unfriendlier. Is that word?
Yeah.
Far more unfriendly, right? Tonight for homework, there's a few of these. There's not an hour's worth of work,
Only 1.
right? And there's only a few of them that are as ugly as this one. Most of them are pretty simple. The complexity of this class continues just like this. If this wasn't new to you today, then tomorrow will be, or the next day. And it never stops. But every day, you got to have your attention on the board. Every day, you got to get to that point where you're like, I don't know why he's still talking. I got my homework in front of me, and I can do it all right now. He can stop talking. You all need to get to that point. And if you don't, then you got to stop me during the lesson. Yeah, Kaylee is the model we all need to follow. She does not let me get any further than her confusion. And then she stops me. I don't get it. But if you're sitting there and you're not asking the question, then the only thing I can assume, I can't call on literally every person, every single question. I call on as many people as I can. I'm relying on you to stop me. And if you don't stop me, then your grade will suffer because of that. So please stop me. Any questions? That was too many speeches for today. All right.
I have a straight nose.
All right. Hey, you guys are eating in the lunchroom today.
And you can just text me after.
What?
You can text me after.
Got the big green name.
Rylan, why are there a whole bunch of red pens underneath your
So you
desk?
gotta collect homework.
It should be going around. It should have been going all around. Who's got the homework basket?
You already collected it.
No, the basket was going around back there somewhere.
Oh, yeah, I think they're over there.
Somebody go grab the homework basket and walk around to the people who did not put their stuff in the basket.
She never got it.
Wait for the bell ring. You still got another red pen underneath.
I'm getting you a pen.
What's this thing with red pens?
Don't give me a fish.
They're on your mind.
I want to
How do they line up underneath your desk? Where do I go? Oh,
Hannah, do you want Philadelphia's painting?
and then Hannah, bring it to me after you're done. Hannah, did you see the one that I posted last night?
Oh, yeah, I did.
Okay, so I'll post another one tonight. Any questions? Well, I'll see you during student advisory. We'll check it during student advisory. Sure. Sure.
I know.
You gonna make it? Yes.
No.
Hey, buddy, how you doing? What are you doing?
Which teacher?
I'm gonna try to suffocate. For real?
I can't breathe.
Yeah, that's
Oh,
There's an easier way of saying that.
you already have pet cactus.
This is why you need to do well in school, so that you can be a psychologist and help kids.
Why?
Why?
Why'd you give them away?
Most teachers don't have that ability to understand things like that. Right? You have a very